You have probably walked past them in museums or seen them in antique shops, those magnificent, heavy, cast-iron stoves from the Victorian era. They are masterpieces of art, covered in intricate floral patterns, chrome plating, and mysterious symbols. The plaque on the museum wall tells you it is a wood-burning heater or a coal stove from the late 1800s. You nod, accept the explanation, and move on. But if you were to actually stop, open the heavy iron door, and think like an engineer for just 60 seconds, that official explanation would crumble into dust, because the device standing before you is physically incapable of burning wood to heat a room. We are taught that the 19th century was an era of steam, smoke, and soot. We imagine stokers shoveling coal into roaring furnaces and fireplaces crackling with logs. But the surviving technological artifacts tell a completely different story. When you strip away the history textbook narratives and look strictly at the metal, the dimensions, and the thermodynamics, you are faced with a glaring impossibility. These so-called stoves possess design features that contradict everything we know about combustion. They lack the capacity for fuel, they lack the airflow for fire, and most disturbingly, they lack the exhaust systems to keep their owners alive. We are looking at the remnants of a lost technology that has been repurposed, crudely drilled, and rebranded to hide a reality that our current energy paradigm refuses to admit. Let's start with the most obvious engineering contradiction: the dimensions of the firebox. In any combustion-based heating system, the size of the fuel chamber dictates the heat output. To heat a high-ceilinged Victorian parlor or a drafty stone hall, you need a substantial amount of biomass burning constantly. Yet, on many of these antique masterpieces, the door to the combustion chamber is the size of a teacup. It is often no larger than a modern smartphone. Try to imagine the logistics of heating a room with a door that small. You cannot fit a standard log through it. You can't even fit a respectable chunk of coal. You would be forced to feed it with wood chips or dust, spoonful by spoonful. If this were truly a wood stove, the homeowner would be enslaved to it. Wood burns fast. With a firebox volume of barely a few liters, the fuel would be consumed in minutes. To maintain a comfortable temperature in a large room, someone would have to stand next to the stove 24 hours a day, feeding it tiny scraps of fuel every 300 seconds. It's an absurdity. No engineer in history, let alone the master craftsman who cast these intricate iron bodies, would design a heating system that requires constant, unbroken manual labor for minimal heat return. The ratio of labor to energy is broken. Unless, of course, the fuel wasn't wood. Unless the fuel was something small, compact, and incredibly powerful that only needed to be inserted once every few months. The inconsistencies get darker when you look for the life support systems of a fire. Fire breathes. It needs oxygen in, and it needs waste gas out. Every legitimate wood stove has a prominent ash pan to catch the residue of solid fuel and a damper to control airflow. But dozens of high-end antique models completely lack an ash pan. Where did the ash go? Did the Victorians have magical wood that burned with 100% efficiency and left zero matter behind? It's physically impossible. If you burn solid matter, you get ash. If you have no ash pan, you are not burning solid matter. Even more dangerous is the ventilation. In a wood-burning system, the chimney is the most critical component. Without a strong vertical draft, smoke fills the room and carbon monoxide kills the occupants. Yet countless parlor stoves from this era have exhaust ports that make no sense. Some are located at the very bottom of the unit. Heat rises, it doesn't sink, so forcing smoke down requires electric fans, which supposedly didn't exist. Others have chimney connections that are clearly afterthoughts. Crude holes drilled into the beautiful artistic casting, often jagged and unpolished, as if someone took a drill to a finished iPhone to add a headphone jack. There are examples of stoves where the exhaust pipe is a delicate decorative tube no wider than a palm wrist. Physics dictates that a wood fire hot enough to heat a room would choke on a pipe that small, backing up smoke instantly.
And then there are the portable units, cast iron heaters on wheels or legs that were meant to be moved around a room. A portable wood stove is a death trap. You cannot move a burning fire without disconnecting the chimney, which vents poison into your house. Yet these devices exist. They sit in museums right now. The only way a portable chimneyless heater works is if the heat source emits no smoke, consumes no oxygen, and produces no carbon monoxide. We are describing a radiator, not a stove, but a radiator that doesn't plug into a wall socket. This leads us to the most controversial evidence found directly on the artifacts, the branding. If you look closely at the cast iron doors of many American and European heating units from the late 1800s and early 1900s, you will see a specific word stamped proudly in the metal. It doesn't say coal, it doesn't say wood, it says radium, sometimes radia, solar, or ray. For decades, historians have dismissed this as marketing fluff. They tell us that radium was just a trendy buzzword like quantum or cyber is today, and that manufacturers slapped it on everything to make it sound modern. We are told these were just ordinary coal stoves named after a scientific novelty. But does that explanation actually hold water? Radium, when it was discovered, was the most expensive substance on Earth. It was valued at thousands of times the price of gold. It was strictly controlled by the financial elites and industrial titans of the era. Why would a manufacturer of common cast iron stoves name their product with a substance that was astronomically expensive unless there was a functional connection? It would be like selling a generic toaster today and printing plutonium reactor on the side. It doesn't make marketing sense unless the consumer understood that the word implied a specific type of performance, specifically fuel-less, autonomous heat.
We know that the public perception of radiation was completely different back then. It wasn't feared, it was celebrated. We have advertisements for radium water for health, radium chocolate for energy, and radium wool for warmth. The official narrative says this was mass ignorance, but what if it was mass familiarity? What if the triangular symbols and sun ray icons found on these stoves weren't decorative, but functional warnings or indicators of the active element inside? The design of the stoves supports the active element theory perfectly. The heavy cast iron wasn't just for durability. Cast iron is an excellent shield and a thermal mass. If you place a small, high-energy capsule, let's call it a thermal battery based on decaying isotopes or atmospheric etheric harvesting, inside that thick metal box, the iron would absorb the intense high-frequency radiation and re-radiate it as soft, safe infrared heat. This explains the teacup firebox. You didn't need room for logs, you only needed a small slot to insert the cartridge. It explains the lack of ash pans. There was no combustion waste. It explains the lack of chimneys. The reaction was closed loop, or produced only trace gases that could be filtered or vented through those tiny decorative pipes. This technology solves the great architectural riddle of the 19th century, the heating of the palaces. Look at the Hermitage in St. Petersburg, the great mansions of Newport, or the sprawling government buildings of Washington, D.C. These buildings have ceilings 20 feet high, massive single-pane windows, and walls made of stone. In the winter, they should be ice boxes. To heat the Winter Palace with wood fireplaces, you would need a convoy of logging trucks arriving every hour. You would need an army of thousands of servants doing nothing but carrying logs. The soot accumulation would turn the beautiful frescoes and velvet curtains black in a week. Yet the interiors of these buildings in photographs from the era are pristine. No soot stains, no piles of firewood in the corners, just clean, radiant warmth. The hypocaust systems and intricate ductwork found in these old buildings are often cited as evidence of central heating. But when engineers examine the brickwork inside these ducts, they find something shocking. The bricks are clean.
If hot wood smoke had traveled through these tunnels for decades, the bricks would be saturated with carbon and creosote. They are not. They look like they were laid yesterday. This suggests that whatever was circulating through those ducts was not smoke, but hot, clean air, heated by a central source that didn't burn organic matter. So what happened? Why are we burning dead trees and fossilized plants today if our great-grandparents had clean, autonomous energy? The evidence points to a massive, coordinated technological downgrade. At some point in the early 20th century, the fuel source, the cartridges, the radium batteries, the etheric harvesters, was withdrawn from circulation. It might have been due to a resource shortage, a monopolistic power grab by the emerging oil and coal barons, or a realization that the technology could be weaponized. Suddenly, millions of homeowners were left with high-tech devices they couldn't power. The radium stoves were useless without the radium. People had to improvise. They drilled holes in the sides of these beautiful units to create drafts. They welded crude exhaust pipes onto the back. They shoved wood and coal into the tiny cartridge slots, cursing the inefficiency, forced to feed the fire every 20 minutes because the device wasn't built for it. The chimney became a necessity, leading to the ugly, exposed stovepipes we see retrofitted into old Victorian homes, punching through walls and ruining the aesthetics.
This transition period is visible in the artifacts. You can find stoves with factory markings that have been crudely modified by hand. You can see the decline in casting quality in later models as the knowledge of how to build the energy chambers was lost, replaced by simple iron boxes designed for burning dirt. The clean, wireless world of the World's Fairs, with their electric palaces and breathless displays of light, was dismantled. The narrative was rewritten. Radium was rebranded from the elixir of life to the angel of death. Radiation became the ultimate taboo, scaring anyone away from researching the technology of the past. We were moved from an energy model of asset ownership to subscription service. If you have a radium stove, you buy the device once and it heats your home for a lifetime, perhaps needing a recharge every decade. You are autonomous. You are free. But if you have a wood, coal, gas, or electric heater, you are a customer for life. You must pay for every unit of heat you consume. You are tethered to the grid, to the pipeline, to the delivery truck. The destruction of this lost technology wasn't just a scientific loss, it was the imposition of an economic shackle that we still wear today. Consider the steam locomotives of the same era. We are told they ran on coal and water. Yet the engineering complexity of a steam locomotive, a mobile power plant capable of pulling thousands of tons at high speeds, is staggering compared to the primitive nature of boiling water with a coal fire. It's like putting a campfire inside a nuclear submarine. Many early photos of railways show no coal tenders, or tenders that are suspiciously small. The water infrastructure for trains, massive cathedral-like water towers, was far more developed than the coal infrastructure. Could it be that the early locomotives also used these high-density thermal units to flash boil water? It would explain the incredible speed and efficiency of the 19th century rail networks, which were built faster than we can build a highway today. When the tech was withdrawn, the trains were retrofitted for coal, resulting in the iconic black smoke and the stoker job, a position that shouldn't exist in a high-tech machine. The ultimate proof lies in the silence of the structures themselves. Visit an old, unrestored manor. Look at the fireplaces. Many are too shallow to burn wood without smoking out the room. They have metal covers that seal the opening completely. Why would you seal a fireplace? Unless the fireplace was actually a niche for a radiator unit, and the chimney was merely a vent for heat dissipation, not smoke exhaust.
We have misinterpreted the function of the entire house based on our limited, primitive understanding of combustion. We look at the past with arrogance, assuming we are the pinnacle of evolution. We assume that because they rode horses, they must have been primitive. But the cast iron evidence suggests a civilization that had solved the energy problem with elegance and efficiency. They didn't need power lines disfiguring their cities. They didn't need gas pipes ticking like bombs under their streets. They had decentralized, point-source energy, and they lost it. The next time you see a 19th century stove, don't look at it as a quirky antique. Look at it as a crime scene. Look for the tiny door. Look for the missing ash pan. Trace the impossible airflow. Read the forbidden words cast in the iron. It is a monument to a stolen future. The technology didn't disappear because it didn't work. It disappeared because it worked too well. And once you see the impossible firebox, you realize that the history of our industrial revolution isn't a story of progress. It's a story of a salvage operation, where we are burning the furniture to keep warm in the ruins of a palace we no longer understand. So the question remains, where did the fuel go? And more importantly, who decided that we weren't allowed to have it anymore? The answers aren't in the history books, but they might just be hidden in the basement of a museum, locked inside a heavy iron box that everyone assumes is just an old stove.